Good day everybody, we got an interesting question. We are expected to have a figure, so I'm in the process of getting the figure. Okay, so this is the square. ABC is a square. ABCD is a square. You got a center here, and this is a circle, full-fledged circle, and you got there is another circle that is going like this. So you have a center here. Now, what I wish to do is I would like to, no, I have given here as find AB. I want to change that AB to O dash. Okay, so let me take this as center O, this center O, this center as O dash. So the question is find OO dash. Now AB is a square, as I mentioned to you. It is given to be of length 10 units. So you will have to get this distance. So let me just use a different color. Okay, I got the color. So let me connect these 2 points. Okay, so OO dash has to be found. AB, as I mentioned to you, is given to be of 10 units. Now this circle is starting from A, so there is a point of contact with the square here. So I should have thickened it, but anyway, I don't want to spend too much time in making this figure close to perfection, so that's fine. So I hope you got the question. Now foremost, what I wish to do is, I see that there is a tangent here. There is a tangent here, and this is 10 units, this is 10 units. So let me find the length of the diagonal. So consider ABD, triangle ABD, right? So there is a 90 degree here. So by Pythagoras, we know, so what do we know? AD squared positive AB squared is equal to DB squared. So I'm looking for DB. I want to know the length of the diagonal. So this is AD is 10 squared, AB is, in other words, AD is 10, AB is 10. So you got DB squared is equal to 100 added with 100, which is 2 times 100. Now this is DB squared. Now I need DB. So DB is equal to square root of 2 times 100, which is root of 2 times root of 100, which is root of 2. Root of 100 is 10 units. So you get DB to be as root of 2 times 10. Okay, let us have that at one corner. Now what I want to do is I want to darken this spot, right? I want to darken this. I know this is going to distort the figure, but that tangency is critical. So what I want to do is I want to, okay, that's fine. So now it's clearly visible. There is a tangency at A. Now I want to mark this point as E, right? So let me state here, the semicircle as tangents AD and DE, right? There is a tangency here, there's a point of tangency here, there's a point of tangency here. So this means since AD I know is 10 units, this means DE is going to be equal to 10 units, right? So that's fine. Now what I wish to do is, I would like to draw a line from O to the point of tangency. Okay, let us draw a line from O to E by the tangent theorem. The line from the center, from O, will make an angle of 90 degrees. So let me draw that. So from O, I am drawing a tangent. So it's a line to the point of tangency. Now because of tangent theorem, this is going to be making an angle of 90 degree. Fair enough. Now if I were to take this point OA, let OA be equal to X, so this is going to be X units, and OB, this entire thing is 10 units, so OB is going to be from this entire length 10, if you take away this X, 10 minus X, this would give me OB, so that is going to be OB. So this side is going to be 10 negative X, fair enough, so that is got. Okay, now as I mentioned to you, DE is 10 units. Now this entire length, let me go over here, BD or DB is root of 2 times 10 units. So but I want only this end, I want only this end. So from, I want to get EB, so EB is equal to, from this entire length, root of 2 times 10, I take away this part, I take away this part. So what is this part? This part D is 10 units, so this is going to be the measure of EB. I hope you're watching it. So let me write that down, root of 2 times 10 minus 10. Okay, now there is a 90 degree here, and that would help us to apply Pythagoras. Now O, from center O to the point of contact A, this is taken as X, that means that's the radius, so this is going to be X, radius. So what I'm going to do is, I'm going to state here, consider OEB, triangle OEB. So by Pythagoras theorem, so what do you know by Pythagoras theorem? PE squared or EB squared plus OE squared is equal to OB squared. Now OB squared is 10 negative X raised to the power of 2, OE is X squared, EB is, I'm going to take 10 out, so this is going to be root of 2 negative 1, this is squared, so this can be rewritten as 100. If you square this, what do you get? You get 2, negative 2 times root 2, positive 1, positive x squared is equal to 100 negative 20 times x positive x squared. So this goes off 2 and 3, that's going to give me 300 negative 200 times root 2 is equal to 100 negative 20 times x. So this can come over here, so that would give me 200 negative 200 times root 2. So 200 is taken out, that will give me 1 negative root of 2 is equal to 20 times x. So cancel a 0, cancel a 0, I got 2 divides here 10 times. So 10 times of 1 negative root 2 is equal to x. So now this is going to be negative 20x, right? This is negative sign, so we got to take that into account. So if this is going to be negative x, so negative x is equal to this, I need x. So x is going to be 10 times root of 2 negative 10. That's the value of x. You can either take it like this, or you can you can take 10 out and write this as root of 2 negative 1. So x value is got. I've got x value. Now I need to go and get O dash. So for that we need to do some alteration in the figure. Now there is a tangent here, right? The circle, let me ensure that the tangent is visible. There is a tangent here. So okay, there is a point of tangency here. Now as I mentioned to you, from O I am drawing a line to the point of tangency. If I were to draw that, that is going to make an angle of 90 degrees. So let me, from O I'm drawing a line to the point of tangency, so that is going to be making an angle of 90 degrees. There is a point of tangency here from, it's actually O dash. So from O dash I'm drawing a line to the point of tangency, so that's going to make an angle of 90 degrees. Now this is a square, this is already 90 degrees, so this is going to be 90 degrees. If I were to take this as R, this is going to be R, this is going to be R, this is going to be R. So we got that out of the way. Having got that, I need to get the value of R. Let's proceed. Okay, our next objective is to find the value of R. Now let me take this point as some f. There is a point of tangency, some f, and let me take, there is a point of tangency here to be as some g. Okay, so according to the tangent theorem, two tangent theorem, if tangents are drawn from an external point, then clearly df will be equal to dg. Now this entire length is 10 units. From 10 units you take a r units, that would give me 10 negative r. If this point df is 10 negative r, dg, which is a tangent here, that is also going to be 10 negative r. Now let me get the value of gb. So what is the value of gb? Now gb is actually this entire length, which is db. From db, this entire length, you take away dg, you take away this length, that would give me gb. Now what is db? This entire length db is got to be as root 2 times 10 units negative dg. This is going to be, what did we get for dg? 10 negative r. So this is going to be 10 negative r, right? So that's going to be, I will write it as 10 times root 2, negative 10 positive r. So this is what I've got for GB. Now after getting this GB, now it is imperative to understand that there is also a point of tangency over here, GH. So GB will be equal to HB. So that is also an important observation. So what we have to do is we have to evaluate, we have to get the value of R. So we need to apply some deductions that we see from the figure. Okay, so as I mentioned to you that GB is equal to HB. So what I want to do is I can now have HB to be equal to 10 times root 2 negative 10 positive R. So this is my HB. Now HC is equal to R. We also know that this plus this is equal to BC. So it's the side of the square. So BC is equal to HB plus HC, and HB is equal to 10 times root 2 negative 10 positive R, and HC is equal to R, and BC is the entire length of the square, and BC is equal to 10 units. So we need to get R, right? So let me write that down here. So this is 10 is equal to 10 times root 2 negative 10 positive 2 times R. I push this to the other side, you get 20 is equal to 10 times root 2 positive 2 times R, and 20 negative 10 times root 2 is equal to 2R. I take 10 out, this is going to be 2 negative root 2 is equal to 2 times R. So therefore R is equal to 5 times of 2 negative root 2. This is the value of R. Okay, fair enough. Now let's go back to the figure. Getting R is just one part of the figure, or I should say it's just only one part of the problem, but we need to get this OO dash. Now what I wish to do is I would like to drop a perpendicular from O dash to AB. So let me drop that. Okay, so this is a perpendicular dropped from O dash to AB. So this is going to be making an angle of 90 degree. Okay, this is making an angle of 90 degree. So let me write that down there. This is 90 degrees. Now having got that, now OB, the entire length OB is 10 negative x. This entire length OB, where did I write that? OB is equal to 10 negative x over here, 10 negative x. So this entire length is 10 negative x. I want to get this part. Let me show you. I need this part. Okay, so x has been found. What is the value of x? X is equal to 10 times root of 2 negative 1. So let me do that here. X value is 10 times of root 2 negative 1, and OB is 10 negative x. So I want to get OB. Why do I need OB? From OB I will take away this R, that would give me this length. So therefore OB is equal to 10 negative of 10 times root 2 negative 1. This is equal to 10 negative 10 times root 2, and then a positive 10, right? Negative negative positive. So this is going to be 20 negative 10 times root 2, which is 10 of 2 negative root 2, right? 20 and 10. So this is my OB. Now as I mentioned to you, let me take this point as I or K, right? Let me get this point as K. I need OK. So to get OK from OB, I have to subtract KB. So OK is equal to, from OB, I subtract KB. Now what is KB? See here, from this there is a point of tangency, O dash to H there is a point of tangency. So I'm just dropping this down. So that is going to be R. So from here to here, that's R. So R is got. So OB is 10 times of 2 negative root 2. Negative KB is equal to R. But I've got the value of R. What's the value of R? The value of R is this. Okay. So substitute that. So this is equal to 10 times of 2 negative root 2 negative 5 times of 2 negative root 2. So this is what I've got. So this is equal to 20 negative 10 times root 2 negative 10 positive 5 times root 2. This can be added, giving me 10, and these two can be clubbed. If I were to take 5 out, this is going to be 2 times root 2 and negative root 2, right? So this can be further simplified. I take root 2 out, I get 2 negative 1, and this can be further simplified. 10 negative 5 times of root 2, which is equal to 10 negative 5 times root 2. Okay, so this is my OK. I got the OK. So let me go here. So OK is got. This is got. Now this all important KO or O dash K has to be got. So what is O dash K? You see that this is actually a rectangle. So O dash K is equal to HB. Right, now we need HB. So what is HB? HB is same as GB. HB is actually got here. We have got the value for HB. So let me write that down here. O dash K is equal to HB, but HB is equal to 10 times root 2 negative 10 positive R. We got that over here. Okay, so the value of R is required, and I know R is equal to 5 times of 2 negative root 2. We have got that value. So substitute HB, the value, and get HB. So 10 times root 2 negative 10. This is going to be positive R. So positive 10 negative 5 times root 2. This and this gets cancelled, and you got 10 times root 2 negative 5 times root 2. This is going to give me 5 times root 2. Because you take 5 out, you get the same thing, 2 root 2 and negative 2. So this is the value that you get. Okay, so this is my HB. Okay, fair enough, I've got HB. So since I've got HB, it means O dash K is got. So this means O dash K is equal to 5 into root 2. So this value is got. Now, as I mentioned to you, I have dropped a perpendicular. This is 90 degree. So I can apply the Pythagoras, right? O, K, O dash. So let me go here. Consider O, K, O dash. Consider this one. O, K, O dash. O, K, O dash. So this is a triangle. So by Pythagoras, we get. So what do you get by Pythagoras? OK squared plus O dash K squared, this squared plus this squared, is equal to O dash squared. We need O dash. So OK squared, what is OK? We have to go see the value for OK. So OK, I just got the value for OK, which is this value, 10 negative 5 root 2. Substitute that. 10 negative 5 root 2 whole squared plus O dash k. O dash k. O dash k is this 5 root 2. So 5 root 2 squared. So this is equal to 100 negative 20 times 500 root 2 positive 25 into root 2 positive 25. This is actually 25 into root 2 squared. This is 25 into root 2 squared, right? You square up the value for 5 and you square the root 2. So this is equal to 100 negative 100 root 2 positive 25 into root 2 square. That's a 2. That's going to be 50 here. That's going to be 50 here. You add this, you get 100 negative 100 root 2 plus 100. These two are added, giving you 200 negative 100 times root 2. And you take 100 out, right? So 100 times 2 is 200, negative 100 times root 2 is this. So this is, so this value you have got is actually the square of O dash. Now what we need to do is we need to actually simplify this. So therefore O dash is equal to, now 100, I can write 100 as 10 squared times 2 times root 2. So this is going to be O dash squared. So I need O dash, which is nothing but square root of 10 squared times 2 negative root 2. This can be rewritten as root of 10 squared times square root of 2 negative root 2. Root of 10 squared is 10, and this has to be placed as it is, root of 2 negative root of 2. If you want, you can take the value of root 2 as 1.414 and perform the operations and give the solution, but I'm okay with this value. So the value of O dash is 10 times root of 2 negative root 2. Please like, share and subscribe to our channel. Until we meet again. Thank you.